All right. So now we know how to solve systems. That means we can solve applications. Where do we first have to turn these words into equations? First one, the state fair is a popular field trip destination. This year, the senior class of high school A and the senior class of high school B both planned trips there. The senior class of high school A rented and filled 8 vans and 8 buses with 240 students. High school B rented and filled 4 vans and 1 bus with 54 students. Every van had the same number of students in it as it did buses. Find the number of students in each van and each bus. How these usually work out is that your variables are given in the last equation. So what am I going to try to find here? I'm going to try to find the number of students in each van and each bus. So I'll call X the number of students in a van, and then I'll call Y the number of students in a bus. So there's my variables. Now let's write an equation using those variables. How this also works, we've seen these word problems before. Each sentence represents an equation. So let me look at this sentence here. A senior class at high school A filled 8 vans and 8 buses with 240 students. So what would that look like using my X and Y?
Let's see.
Huh?
You got 8 buses?
8X.
Yep, 8x.
So I have 8 vans, multiply that by the number of students in each van.
2 plus what?
8x
240 what?
8X what?
plus 8x. 8y.
Plus 8Y, so 8 buses times the number of students in those buses equals
240.
240. So there's equation 1. Next sentence gives me my second equation. High school B filled 4 vans and 1 bus with 54 students. So what does that equation look like?
4x
4.
So 4X
I can't say that fast enough.
plus,
I'll let you get this one.
4.
No.
Hey.
so
No.
Wait, what? I can't say
4
it.
vans.
I can't see. 4 vans,
How many buses?
1.
It's only 1?
Only 1. So 1
I
what?
thought you were comparing vans and buses the same thing. I'm tripping.
Yes and no. Not in the terms of this problem. That equals what?
54 students.
Equals 54 total.
Let's go.
There we go. So there is my system. It's a 2x2 system. What's the best way to solve a 2x2 system?
Graphing.
Is to graph it. So let's go ahead and graph this system.
I hate to say it.
There we go. I look at the solution to the system and I get 822. Now what in the world does that mean in terms of this problem?
That was a sensor, right?
There is
That's where they meet.
8 students in each van and 22 students in each bus.
Very good. There are 8 students in each van and 22 students in each bus. Very nice.
Wow.
Because these are word problems. There is meaning behind the numbers. All right, let's look at the next one, which works pretty much the same. Brenda's school is selling tickets to a spring musical. On the first day of ticket sales, the school sold 3 senior citizen tickets and 9 child tickets for a total of $75. The school took in $67 on the second day by selling 8 senior citizen tickets and 5 child tickets. What is the price of each 1 senior citizen ticket and 1 child ticket? So what are my variables going to be? X, you could call that the
See, 1 senior citizen ticket.
the price. So this is the price of 1, oops, not citizen, senior citizen ticket. And then Y, we'll call that,
Price.
what is going to be what? The price of
1 child.
1 child ticket.
1 child ticket. Okay. So there's my X and Y. Let's look for our equations to write. First sentence here. First day, school sold 3 senior citizen tickets and 9 child tickets for $75. What does that equation look like?
9x.
9x. Oh, no.
9x? X represents,
3x.
Oh, 3x.
3x.
so 3x
Plus 9x.
plus 9y.
Y.
Give me a number.
So the price of my senior They sold 3 of those. The price of my child, they sold 9 of those. And that equals, what? $75.
I like that.
There's equation 1. Equation 2, the school took in $67 by selling 8 senior citizen tickets and 5 child tickets.
So 8x.
So 8x
And 5y.
Okay.
plus 5y
Equals
equals
$67.
very nice. That is correct. There's my 2 equations, a 2x2 system, which I can solve by graphing. So let's look at our graph here.
I want some Cheetos, bro. That's what I want.
And I see that those two intersect at 4, 7. Now, in terms of this problem, what does 4, 7 tell me?
Hold on, Mr. Clark. Let me just right quick.
Boy,
Let me make sure just so I won't.
you put it in the graph?
Okay, hold on.
I'm gonna put it in the graph.
It's not gonna work. It's not gonna work.
Okay, that's how.
Now, no. If you're trying to put this in a calculator, you need to set this to y equals. So you need to move the 3x over and then divide the whole thing by 9.
Yeah, you don't want to
And I'm
do
gonna say that
Now,
it do not show that.
You can't do it like Desmos where you just plug it in. Unfortunately.
So that's why we use the graph on
Technology.
the computer on Desmos, right?
Yeah, I would use Desmos on this entire unit. Skip the calculator. So we got the solution of 4, 7. What does that tell me?
That's where they
What does 4 represent?
4
The 4 senior
senior
tickets.
and then 7
The $4.
So senior tickets cost how much?
$4.
$4. And then child tickets cost,
7.
very good.
it. Sounds reasonable.
Oh, okay.
There's my solution.
That's I'm gonna lie to you, that's how it really be in a real world. That's how much it costs.
Now, this problem you see everywhere. It's probably on the STAR test when you were in algebra,
Oh, yeah.
probably on the SAT. If you take the ASVAB and you want to go in the military, this is probably on there too.
Hell no, are you crazy?
So pay attention.
I hate it.
Sam has 34 nickels and dimes.
Stop that, City.
So he has a total of 34 nickels and dimes. Their total value is $2.35. How many of each does he have?
I remember this.
So again, I'm trying to find how many of each.
Sam has.
So let's call X the number of nickels. Therefore, Y is going to represent what?
Number of dimes.
Number of dimes. Now, using X and Y,
I'm gonna lie, I'm gonna walk with him today.
what's going to be one of my equations?
X plus Y equals 34.
Very good. My total number of nickels plus the total number of dimes equals 34 change. 34 total number of change. Now, what's going to be the second equation where I use the total value of that is $2.35. Here's the tricky part.
Ah.
It's what?
5x plus 25 for Y.
No. No.
What the?
We're close though. No.
It's,
Oh, I'm in dimes. Wait. 10 dimes? 10 Y?
How do you get 30?
Oh,
You gotta
wait,
use it's one of the decimals. It has to be a decimal.
we're talking about money here.
Oh, 0.05.
Okay, very good. So what's the value of nickels? 0.05
X.
times X.
Times plus 5x plus 5 y.
No, plus
I don't know.
0.1
Plus point one.
Y.
Y represents dimes. What's the value of a dime?
10 cents.
10 cents.
10 cents, so 0.1.
Okay.
So there's my other equation.
Jesus.
Now, let's make sure you're paying attention and knowing what's really going on here. If I call this quarters, what would I put here?
25. 0.25.
0.25. If I was calling this dollars, what would I put here?
1.
Just a 1. Okay, very good.
My picture's big.
All right, so here's my 2 equations. Let's graph those 2. Like so. And I get 21 and 13. So what does 21 mean? What does 13 mean?
21 number of nickels
Okay, I have 21 nickels.
and 13 dimes.
Very good. And I have 13 dimes.
We did one.
We did.